here and then bring that. Like, you mentioned I could just use the result from here.
For the first one. Okay, excuse me, I've got something in my throat. My first comment about this is that what he did there is to multiply all the way through the inequalities by A being positive, okay? And that's perfectly legit, right? Because it's really, I mean, he broke it up into two different statements, but it is an and statement. And so it's perfectly okay, and certainly after this section you should feel comfortable with multiplying across and maybe even a large inequality with two or three things in it. As long as you have a positive thing and multiply through, you preserve the inequalities. They go in the same direction, right? And that includes the equals parts. And there's some later exercises about that involve the equals, which are just tedious. But you can multiply through, and if the number happens to be negative when you multiply through, of course you reverse all those inequalities. And if the number is 0, what happens? Well, you probably get nothing. Yeah, right. Well, you get equality. Right. Right. You certainly don't preserve any inequalities, right? All you get is equality all the way across because everything becomes 0. Okay, and you've got to be very careful about that. When you don't know the nature of the number that you have, whether it's positive or negative, you have to be careful about that. And that's, for example, goes back to Phillips, where he took those two different steps depending on the nature of A. Okay, any questions about number 16?
Would we have been able to do it without splitting up the inequality?
Without what?
Splitting up the inequality?
Yes, that's kind of what I'm saying. If, yeah, so you could just go ahead and multiply through that entire inequality since it's even if it was an or statement, you can still, but you wouldn't have it all strung out like that. But when it's strung out, it's just an and statement, and so you can break it up, but then you're just putting it back together. All right, let's see. I took out Roman and Trevor. Okay, and everybody else is in here. Okay, so let's go ahead with, yeah, so 17 has two parts, so I'll get somebody for number 1 and somebody for number 2. Okay, so this person didn't claim number 1, which actually I think it's the easier of the two, but anyway. So Daniel Williams, you're up for 17.1. What did I do with my pen? That's weird. I had a pen. Ah. Okay, so Daniel and Austin gets the second one. Yes, I think yeah. If you guys need to copy stuff down fast because it will go quickly. Okay, something's getting confused in 17.1. Daniel, let's see. Are you trying to prove this by contradiction, like the hint, or?
Yes.
Okay, because,
And that's saying that A will be greater than B.
okay, you need to, I mean, give some indication a little earlier that you're doing this by contradiction. And I think it's not going to be very useful to divide it into two cases for this particular problem.
I mean, I just did it in 2 cases and showed that both proved contradictions. Or created contradictions.
Okay, but what if you're proving this by contradiction? What is this is why I think you need to back up a little bit, because you haven't clearly stated what the assumption is if you're proving by you're saying suppose above, but if you're proving by contradiction, you're supposing that something is not true, right? So I think you should just erase this for a second and well, go ahead and put the by contradiction back, and then okay, or suppose not or something. Okay, right. Okay, so then you're not supposing above, you're supposing that something is not true. So so what's the negation that you would be supposing at this point?
If A is less than or equal to B plus epsilon for some epsilon.
So be careful, when you prove something by contradiction, you suppose that the conclusion is false.
Yeah.
Okay, so what's the conclusion that you're trying to reach here?
A is less than or equal to B.
So if you negate that, what do you get?
B is less than A.
Okay, so suppose B is less than A, right? That would be how you would start your proof by contradiction. Now I think you had the right idea going on there. So now what can you do?
Then B is
Okay, yes, and now what did you want to do? Okay, and why, how can you do that? Is that an axiom, or?
Give me a sec. Oh, that's the axiom saying that there's always something less than, if it's something's positive, and there's also always something less than that.
Yes, it wasn't an axiom though. It was a lemma from the text, right? Okay, so you should say by a lemma, and that so that it's clear what you're using there.
So I can just do this in one step. So
Yep.
Okay. So that's an R equal
And you're done. Yep. And again, I don't require you guys to. Basically, what you're doing down there is summarizing the inequality by the transitive law, right? But it's really preferable to leave it like this, just to steer you away from. First of all, so you realize, and I'll give you perfectly full credit for that, seeing this in there, right? This is what makes the whole thing a strict inequality, right? All you got to do is have one in there somewhere. You can have as many of these as you want, but if you've got one strict inequality in there, you're good, right? From left to right. And that's your contradiction. Okay, so so important thing here, right? When you're proving something by contradiction, and when this happens on the test, if it happens, there'll probably be a proof by some of you will do it, right, at some point. You got to be clear about what you're assuming. I mean, it was obviously you had the right idea down because but there wasn't, and for us out here, we're thinking, what? Assume above, what? I don't understand that, right? Okay, but you had the right idea, and this is part of the reason why you keep working these problems, because you should go back and look at your solution and say, I'm proving by contradiction. Have I clearly said what it is I'm negating? Okay, questions about 17.1? Okay, good. Thank you, Daniel. Okay, Austin.
The way I worked it, I supposed the negation, so there exists an A less than B plus epsilon such that epsilon greater than 0 and A is greater than or equal to B. So I solved for B minus A is greater than 0, and then over here I took A minus B is less than epsilon. So by transitivity, I put epsilon is greater than A minus B, which is greater than or equal to B.
Okay, let's back up for 1 second. Let's again go back to so you're planning to prove this by contradiction, right?
Yeah.
Okay, so once again, the question is, what are you negating?
I suppose the negation of this.
Okay.
Is that not-
Okay, right. So what you're doing is you're basically proving the negation of this statement.
Yeah, I'm saying the negation is true, therefore
Okay.
what we negated must be false.
Okay, that's a reasonable, I mean, that's logically correct to do that, but again, it's a matter of not being sufficiently lazy about it. Okay, this is a lot of work, and it's good practice, but when you're on the test, you don't want to try to prove the negation of something. Sometimes it's very difficult to do, or it just involves finding an example. So my suggestion would be, and I haven't looked this through yet to see whether the proof of the negation is right. It may well be, but what I'd like you to do, just to help everybody get a solution that you could do efficiently on the test, and that is just to come up with some A and B, for which this is.
Oh yeah, I came up with A equal to B.
Okay, good. So there we are down at the bottom. So all the stuff prior to that really isn't necessary. Okay, so now here's the concrete counterexample, A equal B equals 0. Okay, and then when you have a counterexample, you have to check everything, check the hypothesis. So where are you checking the hypothesis now?
Well, I'm checking that this holds true, and I'm plugging in 0 right here for each part for A and B, and it shows that epsilon is still greater than 0, which is true, and since A minus B is greater than or equal to, I just took one case since there exists. So.
Okay, the only thing I'm concerned about is that you concluded epsilon bigger than 0, which is true. But remember, you can't prove something, show something by concluding that something is true. You have to start with something that's true and reach your conclusion. So let's just back up, right? You can't start with what you want to show and reduce it to something that's true. If you do that, you have to check that your logic goes backwards, right? Because you can start with false things and conclude true things, as we've seen. So let's just back up for a second and just do this as a simple verification that A equal B equals 0 is a counterexample. So what you need to do is check. First of all, check the hypothesis that
A is less than B plus epsilon.
yes, so just plug in 0 for A and B and just point out that it's true.
Which is true.
And your arrows go backwards though if you want to do that, right? So because you're starting with the true thing, right? Okay, right. So A equal B equals 0 satisfies the hypothesis. And then you just need to point out that the conclusion is false. The conclusion of your original statement is false.
Yeah. Therefore, this is shown to be true, so therefore our first statement must be
Okay,
false.
but what is the conclusion of your statement?
Meaning that
Your original statement. Go back to your original statement. What's the conclusion?
A is less than B.
That's your conclusion. Okay. Now is that correct in this case?
No.
No. And that's it.
Okay.
Okay. So since so to finish this, so you can, just go over to the right, okay? And since 0 less than 0 is false,
A less than B is
no, just the statement is false. The statement is false. Okay, so let me go through, and this is why I keep